Hello, I'm Mike Traskos. I'm the Chief Engineer and EWIS DER at Lectromec. This presentation is one that I recently gave at an interagency meeting, and this presentation is on the Electrical Wiring Interconnect Systems Risk Assessment for UAVs. When I'm talking about UAVs in this presentation, I'm talking about the larger vehicles, not the standard quadcopters, but the heavier vehicles, such as those weighing more than 200 pounds. In this presentation, I will talk a lot about risk assessment and steer away from discussions about design. Although EWIS design does have a significant impact on overall EWIS risk, I want to focus purely on the risk assessment itself. Because at some point, UAVs will fly in civilian airspace, and they're going to need to be certified by the local authorities, and any part of that may include EWIS. In this presentation, I will focus on how those ideas from standard commercial and civilian aircraft can get into UAVs and help improve the overall reliability of the system. Now, risk assessment is not a new idea. It's been around for centuries. And because of that, there is a large body of knowledge that exists and can help with risk assessment of any system. Now, for engineers from any system, they will certainly say that their system is different and that they're special. And of course, their system is unique, and there are some specialized techniques that will be necessary to evaluate the system, but for the most part, you can take existing approaches and apply them to get valuable information, and that can be used to improve the design, and in this case, obviously looking for the certification of the vehicle, in particular, the EWIS. The best examples right now that exist for guidance of certification of EWIS are from the FAA. The FAA has provided a lot of good information and guidance in this area. It does take time to read through all this material, but eventually all those concepts are discovered. When we talk about risk, it really comes down to two parts: the severity of failure and the probability of failure. The FAA already defines this for multiple areas in terms of the severity of failure, from minor events to catastrophic, and then breaks it down to the different weight categories of the vehicle. Your lighter passenger vehicles have a lower threshold for liability and risk, whereas your larger vehicles, your commercial transport vehicles for example, have a much higher requirement. For example, your commercial vehicle requires a 10 to the minus 9th failures per flight hour. What that means is that you could expect a catastrophic event once every billion flight hours. When we look at UAVs, they range in weight, and this might be how the FAA will eventually break down the certification requirements in the future. If we look at EWIS regulations as they exist today, there are quite a few that are related to EWIS, as you see here, but there are only two that really matter in terms of risk assessment. There's 25-1707, which is the system separation requirement. If you'd like to know more about this, we really have a great white paper on our website, but here we're going to focus on 25.1709. 1709 is a straightforward requirement that does take some time to understand. 1709 specifically states that each EWIS must be designed and installed such that each catastrophic failure condition is extremely improbable and does not result in a single failure, and each hazardous failure condition is extremely remote. That type of idea, that concept, can be easily applied to UAVs. The key question here for hazardous and catastrophic events is really, what is the probability of failure? How do we move forward in terms of certifying these vehicles at some point? Those definitions will become a key part of how these systems are designed. Now we're going to focus purely on the risk assessment portion of Advisory Circular 25.1701, which is the FAA's guidance provided on risk assessment of EWIS. Here you see the flowchart. It's kind of hard to read, but you can get a high-resolution photo on Lectromec's website. This excerpt from the FAA's Advisory Circular provides a pretty good description of what is expected from an EWIS risk assessment. The left side of the chart covers physical failure, and the right side covers functional failures. If you look at the physical failures, you want to avoid any single failure condition, such as damage caused by an arc event. we go through the physical failure side, the guidance states that an arc fault should be assumed regardless of the probability. What needs to be determined through testing or analysis is the separation distance. It will be different for different harnesses, different parts of the vehicle. As you see in this figure here, we have one separation distance from a fuel tank and another separation distance from a wire harness because those different components have different sensitivities to arc damage. Now, how do you get the data to support design and certification? That is something that Lectromec can help you with. We have a laboratory and the engineering capabilities to help you both with new aircraft design and aircraft modification. As I mentioned earlier, we have a great white paper on system separation and a lot of information on our website. Here are a couple examples of arc damage, and these are some from our lab and some from in-service failures. If we go over to the functional side of the chart, it really comes down to taking the existing documents for system evaluation and integrating EWIS into them. Your functional hazard assessment, your preliminary system safety analysis, and so forth. Why should EWIS be considered here? It is because it is important to identify if EWIS can contribute to a single point of failure in your aircraft. What is the functional impact of a connector disconnecting? What if there's a pin-to-pin short in one of those connectors? What are those functional failures? These are some of the functional failure considerations that must be made during the functional failure assessment. One design practice that's starting to improve the reliability of commercial aircraft is distributed power. In this example here, you see that a power source here, or at the central computer, sends information down to a device here at the bottom left. As you see with this network design, there is a lot of redundancy in the EWIS, so you can lose several of these components along the distribution and still maintain the reliability of the overall system. In the case where you lose one of these components, it's still possible to reroute the power or signal multiple ways. This is a comparison with the classic aircraft power system design where you just have the generator, circuit breaker, and device. With the classic design, it is pretty straightforward to do an evaluation in terms of the probability of failure. Now that you have all these different paths with distributed power, obviously you increase the reliability, but by how much? That analysis, that type of failure evaluation, becomes a lot more complex. As you can see here with the formula at the bottom of the slide, it becomes a lot more complex. And if you're looking for ways to evaluate this and perform an overall robust analysis of your aircraft's EWIS, Lectromec's EWIS risk assessment tool can help you solve and reduce the complexity of these problems. Now, these are just some of the ideas that need to be considered today, but as we move forward with the possibility of certifying UAVs, the tools for EWIS risk assessment already do exist. There's no reason why these principles from commercial and general aviation cannot be applied to UAVs. It may be more difficult with the size of these aircraft, it may require more weight on the vehicle, but it can be achieved. What remains uncertain is what will be the certification basis for these vehicles. Will they be similar to general aviation? Well, right now, general aviation does not require risk assessment of EWIS, and the UAVs are obviously of similar size to these vehicles. Secondly, as the FAA considers the implication of UAVs, where the reliability threshold will be placed will become very important. Thank you for your time today. If you're looking for more information about this topic or any EWIS related topics, we have plenty of articles on Lectromec.com. If you're looking for information on component testing, system certification, or EWIS risk assessment, contact us. We'll be happy to talk with you. Thank you.